any doubt in this?
No.
So basically, we were doing ethanol, right? In which the last reaction was reaction to give unsaturated, that means doubly bonded. Now we are going to start another compound, that is ethanoic acid. This is your ethanoic acid. And ethanoic acid is CH3COOH. This is your ethanoic acid. Now I'm going to write some properties of this or characteristics of ethanoic acid. Please do write with me. It is commonly called acetic acid. Its common name is basically acetic acid. It belongs to a group of acids, and that acid is called carboxylic acids. Next point we can write 5 to 8% solution of acetic acid in water is called vinegar. Is called vinegar and is used as preservative in pickles and is used as preservatives in pickles. To preserve pickles, we use there this vinegar. We can also write about its melting point. Melting point of pure ethanoic acid is 298 Kelvin. So please do write these points about it. Do let me know when you are done with this.
Okay, sir. Cancer.
Very good. Now we are going to see the reactions of ethanoic acid. Reactions of ethanoic acid. In which we have the first esterification reaction. Ester is also a functional group like carboxylic acid. And here the first reaction of ethanoic acid is esterification reaction. That means basically in this reaction we prepare or we form or produce ester. How we are going to produce ester and what is this or what is this esterification reaction? So basically, wait a minute. When an acid, that means carboxylic acid, not mineral acid, organic acid, and an alcohol react, then esters form. Then ester formed. How the reaction takes place? So you can write about this ethanoic acid because we are going to react this ethanoic acid with alcohol. So ethanoic acid reacts with ethanol, or we can write absolute ethanol, that means pure ethanol. Absolute ethanol in the presence of an acid, in the presence of an acid catalyst. This acid will be acting as catalyst to give an ester, to give an ester. I'll show you the reaction. It's quite easy. You know, the ethanoic acid has a chemical formula this. It is going to react with ethanol, which has a chemical formula this. And this reaction will be carried out in the presence of acid, which means you can either write acid or H plus. Then what will be the product? The product will be CH3, C double bond O, OCH2, CH3, and along with elimination of H2O, not 2H2, it's H2O. So you have to remember this reaction. It's very easy and important. Ethanoic acid reacting with ethanol in the presence of acid, then ester will form or it will give ester. Please do write it. Let me know when you are done with this. I will give you a simple trick to remember the reaction. See, I'm going to give you a simple trick for this reaction. Can I write this CH3 C double bond OH as it is? And I'm going to write it in reverse like this OH, and then there is CH2 CH3. Is there any doubt in this? Can I write this? Yes or no?
Yes, sir.
Now see what you need to do. Just remove water. And how you are going to remove water? Let me do one thing. Okay, I'm going to write it as this. Now, now remove water. Water will be removed like this. Of just wait a minute. This is your H and this is your O. Now I'm going to remove the water. So here, how I just removed water. If you are going to remove this water, just bond this to this, and you can see this two hydrogen and one oxygen will form H2O, and you can see the rest part CH3. Then there was C double bond O. Then there is directly this carbon is going to bond with this oxygen. This carbon is going to bond with this oxygen, so it will be O, and then CH2 is there, and after CH2 there is CH3. So it's very easy, and this is your ester basically. This is your ester. I forgot to write. So you just need to remove the water, and in this way you can remove the water, and you can see the product you have formed is correct. Please do write it if you want. Are you done with this?
Yes, sir.
No, okay. Now we are going to write some points about this ester, which is quite easy. So the first point we can write is esters are sweet smelling. That's why they are used in perfumes and all. Esters are sweet smelling substances. Sweet smelling substances. These are, write with me, these are used in making perfumes, making perfumes, and as flavoring agents. Flavoring agents. Next point, which is very important. And this is a reaction. Basically, when you are going to treat this ester with sodium hydroxide, you will get you will get an alcohol and a carboxylic acid salt. So I'm going to write on treating with sodium hydroxide, which is an alkali, which is an alkali. The ester is converted back to the ester is converted back to alcohol and sodium salt of sodium salt of carboxylic acid, sodium salt of carboxylic acid, and the reaction is known as I will explain these points. First, write with me. The reaction is known as saponification reaction. Saponification reaction. Because it is used in the preparation of soap. In the preparation of soap. So basically, first of all, you have to be careful when you are going to react ester with the sodium hydroxide, which is an alkali. Alkali, that means basically base. Then ester is converted back to alcohol and sodium salt of carboxylic acid. It will be converted into sodium salt of carboxylic acid. I will show you the reaction, and the reaction is known as saponification because this reaction is used in the preparation of soap. Okay, so there can be a lot of question. Can be a lot type of question like why the reaction is known as saponification. Saponification because it is used in the preparation of soap, and reaction is very important. Please do write it and then let me know. After this topic, we have soaps and detergents. Then our syllabus for the board will be over.
Done.
Very good. Now see, I'm going to show you the reaction. So reaction is quite easy. You can see this is your CH3 and there is C double bond O and O, that means C double O and CH2CH3. So if you are going to treat this with sodium hydroxide, which is a base, which is an alkali, so it will be converted into C2H5OH. You can directly write, or either you can write if you want to write it, CH3CH2OH. The alcohol will be given back. Again, the next will be CH3COOH. This is your carboxylic salt, but we will get carboxylic acid salt. That means that hydrogen will be replaced by this metal, sodium, and this is your carboxylic acid salt. And this reaction is known as saponification. Is that clear?
Yes, sir.
Why it is known as saponification? Azaan, why it is known as saponification?
Yes, sir.
Why this reaction is known as saponification? Can you answer
Sir, your voice is little.
it? I'm asking why this reaction is known as saponification. Am I clearly audible?
No, sir, your voice is little bit cracking, sir.
Oh, am I audible clearly?
Sir, you are audible but clearly no.
Okay, wait a minute. Just write with me. Am I audible clearly now?
Yes, sir.
Okay, what I was asking, why this reaction is known as saponification? This was my question. Why this is known as saponification? Is my voice not clear?
Sir, now it's clear, sir.
Okay, can you answer me? Yes or no?
Sir, sir, because
Because it is used in the preparation of soap,
soap.
right? Yeah,
Yes,
yeah.
sir.
Now, please, this a reaction with the base. So you know that when acid react with the base, salt plus water will form, right? So ethanoic acid is also an acid when it is going to react with a base such as sodium hydroxide to give a salt, and that salt has a name that is sodium ethanoate, or it is also known as sodium acetate and water. Please do write it. Do let me know when you are done with this.
Done, sir.
Done. Very good. Now see, I'm going to show you the reaction. You're going to take ethanoic acid. So this is your ethanoic acid, and you are going to react this with NaOH. So what will happen? This hydrogen's place will take sodium. So it will be sodium ethanoate, and H2O will be also formed. Because you know that acid react with base to form salt plus water, right? Salt plus water. Let me know when you are done with this.
Done, sir. Done.
Very good. Now we are going to react this with sodium hydrogen carbonate and sodium carbonate. So the third reaction is basically a reaction with carbonates and hydrogen carbonates, or you can also call it bicarbonates. Then salt plus water plus carbon dioxide will form. So I'm going to write a point with this. Please do write with me. Ethanoic acid reacts with carbonates and hydrogen carbonates and hydrogen carbonates to give a salt, first a salt, and then carbon dioxide also, and water. As I told you this, and water. The salt produced is commonly called sodium acetate. Sodium acetate. Acetate. Do let me know when you are done with this.
Done, sir.
So it's very easy to understand. As I told you, when you are going to react an acid with sodium carbonate or sodium hydrogen carbonate, the product will be salt, and this salt is commonly called, its common name is sodium acetate, and H2 and CO2. This is 2 because to balance it only. So same product, sodium acetate this is, and then H2 and CO2. Okay, can I change the slide?
Yes.
Now we are going to start a very important topic from this chapter, that is soaps and detergent. Soaps and detergent. So write some points with me and then I'll explain. As I in you have seen in saponification, that saponification reaction is basically why it is called saponification, because this is used to prepare soaps. So basically soaps are sodium or potassium, sodium or potassium salts of long chain long chain carboxylic acids. That means basically any carboxylic acid, you can see this is your carboxylic acid, and if you are going to replace this hydrogen with a metal like K or sodium, this will be a salt. Is that clear? So
Yes.
basically soap is what? It is a long chain of carboxylic acid salt. Carboxylic acid salt. So you can see soaps are sodium or potassium or potassium salt of long chain carboxylic acid, and the ionic, I'll show you which one is ionic and which one is uh, covalent. So the ionic end of soap dissolve in what? Dissolve in water. The carbon chain, the long alkyl group carbon chain dissolves in oil. Dissolve in oil. So this is the scene. If you have a long chain alkyl group in which this will be like this is your ionic end. I will show you what is this ionic end, and this will be your long chain of carbon. This ionic end is hydrophilic. Hydrophilic end, that means it is water attracting part. Hydrophilic, and the long chain carbon is basically hydrophobic end. That means it will repel by water, or it will repel water. Hydrophobic end. If you are going to see an example of salt, that is C17H35, COO negative, Na plus. So this will be your basically ionic, and this will be basically hydrohead or hydrophilic, and this will be your tel. Tel. We also call it tel. Tel, and this is your head. Are you getting my point?
Yes.
Please do write with me. So this is a example of salt which has a name, sodium stearate. Sodium stearate. Let me know when you are done with this. Let me know when you are done with this.
Done, sir.
Now we are going to talk about this detergent. So write a point about detergent. There is difference between both of them. Detergents are generally ammonium or sulfates, salt of long chain carboxylic acid. Long chain carboxylic acid. Please do write it. So basically, that is not sodium salt, it is sulfate or ammonium salt of carboxylic acid. So I'm going to give you an example which is very easy. You have seen that this is C17H35 COO negative and ONA. This is your soap. Now what will happen? This C17H35, if sulfate ion comes in this, or either sulfate or you can see with the sodium or potassium, this will be detergent. This is the difference. Are you getting my point?
Yes, sir.
Please do write with me. Just write it and then let me know. Next class, the chapter will be completely completed. Let me know when you are done with this.
Done, sir.
Very good. Now write some points about cleansing action of soap. Cleaning action of soap. Most of the dirt is oily in nature. Most of the dirt is oily in nature. And oil does not dissolve in water. Write with me the points that I'm writing. The soap molecules The soap molecules form the structure called micelles. Called micelles. I'll show you what is micelles. But first try it with me and we will see about it. Next point. In micelle, one end is towards oil and the oil droplet and other end which is ionic faces outside, which is ionic faces outside. I'll explain with the help of a diagram which is quite easy. So you are going to write this with me. Soap in the form of a micelle in the center of the micelle. The micelles stay in the solution as a colloid and will not come together to participate due to ion-ion repulsion. Soap micelles are large enough to scatter light. Soap solution appears cloudy. So first you are going to write it, then I'll show you. Okay, please do write it and then you may go. I have taken the screenshot of the question. It is not a question.